Good morning and welcome to Algebra 1. Today we're just going to go over how to do some of the problems that are practice for your quiz because we have half the class doing photo day and the other half the class at home. I'd rather give you guys all some additional practice material. So let's start off with a proof. So with the proof process, we're going to get a problem like this. We got 4 plus 2 parentheses x minus 5 equals 10x plus 2. All right, so our goal here is to solve the problem and provide the reason for each step that we take. So I'm going to begin with a distribution. Distribution is multiplication of one term into parentheses that it touches. So I'm going to take care of that now. 4 plus 2x minus 10 equals 10x plus 2. Now, I only distributed, of course, to this parenthesis set. I didn't do anything on the other side of the equation. What allows me to have done that? It's the distributive property. We can abbreviate for right now, but it's the distributive property. Now, I have choices of what to do next. I could subtract 4 from both sides, subtract 2x from both sides, add 10 to both sides, subtract 10x from both sides, subtract 2 from both sides. There's so many choices. What do you want to do? I'm going to combine like terms. I have on this same side of the equation a 4 and a negative 10. They're like terms because they're both constants, and I can just do the actual subtraction that's being implied. 4 minus 10 is negative 6. Plus 2x equals 10x plus 2. I combined like terms, which is the reason we give for the action we took. Now again, I have choices. I'm going to choose to add 6 to both sides. I just feel like it. Gets rid of the constant from this side and puts it on the other side. I have to add because the 6 was negative. Now I'm left with 2x equals 10x plus 8. What let me do that? Well, this time I added, so it's addition. But because I did it on both sides of the equal sign, it's a property of equality, which we can abbreviate POE. Now, I have a variable term on both sides as well, 2x and 10x. I don't want that. However, I only have one term on this side. I don't want to touch it. So I'm going to subtract the 10x from both sides. That cancels out here. And 2 minus 10 is negative 8x equals 8. What let me do that? This time it's subtraction, property of equality. Lastly, I always want to divide by the coefficient of the variable. That's divide by negative 8. Both sides. X equals negative 1. I've solved it. What let me do that? The division, property of equality. And that gives us our answer with all our reasons. Distribution property, combine like terms. Addition, property of equality. Subtraction, property of equality. Division, property of equality. The only property we didn't cover just now is the multiplication, property of equality, but we also didn't multiply on both sides, so there was no reason to use that one. Another example of what you'll be asked to do is a proportion. So let's try one. 3x minus 2 divided by 8 equals x divided by 4. We do cross products with proportions. Cross products is cross multiplying. So we multiply on a diagonal. So this 8 and that x are going to multiply. I'm going to say 8 parentheses x for now. Equals comes next. And then the other cross product, 4 times 3x minus 2. That's a binomial. It's got two terms. Got to be very careful with those. It's 4 and then parentheses 3x minus 2. It's a good step to take because it's going to remind you that you have to distribute. 8 times x is 8x equals. The 4 distributes to both of these terms, and I get 12x minus 8. Once again, I have a variable term on both sides, which I don't want, but I've only got the one term here, which I don't want to remove. So I'm going to subtract 12x from both sides to get my variable term only on one side, but also keep my equation easier to solve. 8 minus 12 is negative 4x. On this side, it equals negative 8. Last step is to divide by the coefficient of the variable, which is negative 4, which cancels there. X equals 2. We solved the problem, and I discussed as we went the right steps. Some people call this a butterfly method because it looks kind of like a little butterfly we drew with the cross product circles. But in any case, it's cross multiplication or cross products. Okay, we also are going to have special cases. Now, you've seen several examples of this while we were working in class. Special cases are when you're solving the problem, but the variable term drops out completely, leaving two numbers, one on each side of an equal sign. And if it's correct, like 3 equals 3, we'd say it has infinite solutions, all real numbers. But if the two numbers are not equal, 0 equals 5, we'd say there's no solution because, of course, that's a false statement. Here's an example. 6 minus parentheses 2, x plus 1, close parentheses, equals negative 2x. Let's distribute. Now, again, never do 6 minus 2. 6 minus 2 is 4, but that's not what you have to do because it's not the right order of operations. This multiplication has to get done before you would ever consider subtracting. I'm going to distribute that 2, or you could even consider it a negative 2. 6 minus 2x minus 2 equals negative 2x. Now I have a 6 and a negative 2 on the same side of the equation, so I can combine those terms. 6 minus 2 is 4, minus 2x equals negative 2x. You might notice right here we have the same exact variable term on both sides of the equation, which is an indicator that we do have a special case. I know I want the variable only on one side, so I'm going to add 2x to both sides to move it, but what happens is I get 4 equals, well, that also cancels, like 4 equals 0. Well, 4 does not equal 0, obviously, which tells you, since the variable term dropped out and the result is untrue, that there is no solution. You could write no solution, or you could write the empty set notation, either which way. That's one of our special cases. Here's another one. 4 parentheses 2x minus 3, close parenthesis, equals 8x minus 12. Once again, we know we have to distribute. 4 times 2x is 8x. 4 times negative 3 is minus 12. And on this side, we have 8x minus 12. They're identical. They're completely identical. There's no difference whatsoever, which tells you right away we got a special case on our hands. But if you don't see it, let's keep working. I'm going to subtract the 8x from both sides to try to get my variable expression only on one side. So it cancels here. I got negative 12 equals, it cancels here also, and I have negative 12. The variable term is gone, but the resulting numbers are identical. And that tells you that there are infinite solutions. Infinite solutions. We also can use the infinity symbol. Okay? Those are the two special cases. So we talked about special cases, solving proportions, and proofs. One other thing that's come up while we've been going over these things is that we talked about clearing fractions a little bit, but it seems like it's a sticking point. So let's just do another couple examples of that. I'm going to say we have 3/4 x plus 2 equals 5. If I want to clear the fraction, it's not that hard. First, I could subtract 2 first, whatever you really want to do. Let's just say I don't subtract 2 first. I'm worried about the fraction, so I don't even notice I can subtract 2. You can always get rid of a fraction if you multiply the entire equation by the fraction's denominator. All right? And there's also a way to do that when there's two different fractions. I'll show you that next. But let's just multiply the whole thing by 4, which is the fraction's denominator. Here's why this works. If you were just to multiply, 4 times 3 is 12. And if you divide it by 4, you get 3. Also, you can see that this 4 and that 4 are going to cancel each other out, which is the reason we're doing this. So by multiplying by the denominator, I actually make my fraction just become 3x. There's no more fraction there anymore. But I must multiply the 4 times the 2, so it's plus 8, and the 4 times the 5, so it equals 20. This is an example of the multiplication property of equality. I'm going to subtract 8 from both sides, and I get 3x equals 12. And now I'm going to divide everything by 3 to get my answer. Turns out x equals 4. Done. Without really having to worry about fractions. Let's do one more where there's 2 fractions, and they have different denominators. I'll say 1/2 x minus 3, we'll go with 3/5 equals 2. Now, I have 2 different denominators. I'm still going to clear the fraction by multiplying by some number, but it's not going to be that 2, and it's not going to be that 5. It's going to be their least common multiple. The easiest way to do this, just multiply them together. 2 and 5 is 10. I'm going to multiply the whole darn thing by 10, putting it over here because I ran out of room over there. So 10 times 1 divided by 2. What is 10 times 1? Well, that's 10 divided by 2 is 5. So that becomes 5x minus 10 times 3 is 30, and 30 divided by 5 is 6, equals 10 times 2, which is 20. Multiplying by their product canceled out both fractions and gave me a problem that's easier to solve. Let's add 6 to both sides, and we get 5x equals 26. We divide both sides by 5. X equals, if you want to leave it as 26 over 5, that is actually a reduced improper fraction. It's okay. If you want to make it a mixed number, 5 goes into 26 5 times with 1/5 left over, or make it a decimal, it's 5.2. It does terminate, there's no problems there. That's a review of pretty much your entire quiz. So you'll get your quiz Tuesday or Wednesday. Actually, it might be Tuesday or Thursday now because Wednesday is an SAT day. So I'm not going to give you guys, since you're going to be on distance learning on Wednesday, I'm not going to give you a quiz at home. So we'll make it Thursday or Friday, whenever you're in school, whatever your cohort is. Anyway, if you have questions or problems or any issues, please let me know. Send me an email or a comment, and I'll be happy to help you out. Otherwise, let me know whenever you have a question. I'm always going to be here. Have a great day.